Hi and welcome to a very exciting new Swift tutorial. Today we're going to create a simple iOS game and writing it completely using Swift. So what are we going to create? This is the game that we're going to do. It's very simple, kind of a space invader. There are alien ships that are moving from the top and you have to catch them all. And as soon as you have enough of them shot, you will win the game, and as soon as one reaches the bottom line of your screen, the game will end. So that is what we're going to create today, and let's get started. Let me just say that you're getting all the assets for the game you need, so you can download the images and the sounds that we're going to use in the description below. And we've got 3 images. One is the alien ship, one is our own ship, and a cool photon torpedo. And we've also got this cool photon torpedo sound, which sounds like this. And the very exciting game music. So let's get started. Open Xcode, and we will get right into it by using the game template that is providing us with our starting point. We're going to create a SpriteKit game. So the game technology we're going to use is SpriteKit. We're of course using Swift as our language, and we'll just call this space or space game or whatever you want. And let's create it and let's get started. So the first thing we're going to do is actually preparing all the assets that we will need during the development of this game. So start by with right-clicking on your storyboard or your view controller, and let's create a new group. And we have to name this something like sprites, and the extension is important because Xcode is going to take this extension called Atlas, and when building the project, it'll do some great stuff so that we can use it easier within our code. So let's call this sprites.atlas, and we will directly move all our images into this new group. And we have to make sure that the destination, that we say copy items if needed, and also add to targets space in this case, and say finish. And now we have all our assets in our sprites group, and we will just create another group called sounds, and we will just drop both of our sound files into this new group. And now we're good to go, and we'll start by making one last adjustment and saying that we are just using our app in portrait mode. So when we're going to start, then we can see that Xcode has given us a really cool template which already says hello world, and you can see how many nodes. This is called a node. It's a label node, and if we click on the surface here, it'll create some cool spaceships for us, which are rotating, but we're going to remove all that stuff and replace it with our game material. So let's stop this and let's go into the game view controller.swift. The first thing we want to do actually is to comment out all these things within view.load. You could also remove it, but I'm going to show you how to build this from the ground up. So we are going to get some music playing right away. So First things first, we're not going to use view.load, we're going to use view will layout subviews because this is happening earlier, and we're going to need it for sizing purposes, so that we can initialize our game scene, which we're going to use in a minute, in which all the designing stuff will take place, and this is just a better place to start off. So let us override the view will layout subviews method, and if everything works as we want, then Xcode should do this for us. Override function view will layout subviews, open curly braces, give us some space here. I'm going to close this one here and maximize this here. And now we will start using our background music. So first we're going to create a variable, call it bg music URL, which is of course a ns URL, and we will initialize this with ns bundle, main bundle, and we will ask for the URL for our resource with extension. So our resource is named bg music, and the extension is mp3. So really easy so far. Let's now create this this music player, which is located in AV Foundation. So we have to import this first. Import AV Foundation. We have no code completion here, but as soon as you build it, you will see that this works just fine. And now we will make an instance of a AV audio player. So let's do that right below our class definition. So let's create an object, background music player, AV audio player, and initialize it directly here. So now let's return back to our view will layout subviews method and do some adjustments to the music player. So the background music player is going to be AV audio player, and we will call contents of URL. So we've got our URL already. This is bg music URL, and we'll just leave the error and set it to nil. And now we have to specify a number of loops, and because we want to loop our music indefinitely, we can set the number of loops to -1. And this actually will loop the whole music indefinitely. So now we have to call the prepare to play method, and for the last, just play. And if we run our application, we should already get cool sound. That's cool. The hello world is gone, and we are going to create a we're going to call our scene and show this right now. So let's first create a SK view which is the SpriteKit view, and this is self.view as SK view. We have to cast this for type safety. Next thing we're going to do is actually decide whether we want to show the FPS label and the node count label. So let's say for now skView dot shows, actually use this one, shows FPS, set this to true, and shows node count equals true. Alright, now let's create the scene, which is of type skScene. And this is actually the scene that we're going to write in this GameScene.swift file. So we have to use the GameScene class to initialize this. So let's call GameScene and call scene with size, and we're just going to use the bounds of the skView and the size of the bounds to initialize our game scene. Now we have just to adjust the scale mode, and we're going to use skScene scale mode aspect fill. And I'll just use the skView and say present scene. And this is, of course, our scene. So now we should see our hello world again. So far, so good. And now we can dive right into the game scene class and begin with creating some properties. So let's go directly below the class definition. And let's create, first of all, our player. Our player is a SK sprite node. All objects that we're going to place on within our scene are called nodes. So let's create this sprite node and initialize it. And now let's create another property called last yield time interval. It's NSTime interval equals NSTime interval initializer. I'm going to explain these properties in a second. Let's just finish the last two ones. Last update time interval, NSTime interval, and a simple count for aliens destroyed. Just an integer, set this to 0, which will count how many aliens are already destroyed. And we're going to use these two properties to decide when we have to create new aliens, and we're going to use them later in this tutorial. So let's start by writing our own initializing method. We can actually just delete or comment out this stuff that is responsible for creating the label, but we're going to write our code, our first code, within an init method, which which gets the size as CG size, and we have to call super init and pass the size to the superclass. So let's give it what it wants, give it a size. First of all, our game is within space, so let's give this scene a darker color. Let's say self.background color and use the proper methods here. This is skColor, SpriteKit color.black color. And we have already now our black background color. And we will then directly begin and create our player object. So let's call player and initialize it with the correct image, which is skSprite node. And now we will use image name just like you would use UI image named. And this is our shuttle. And now let's give it its initial position, which is player.position equals CG.make self.frame size.width and half of it. So we're going to place it in the middle of the screen when we talk about the x-axis, and now we will just set it player.size.height divided by 2 plus, let's say, 20, which will move it up from the bottom about 20 pixels. And you should note that the coordinate system isn't starting in the upper left corner of the screen like it does in iOS ordinarily. It starts in the lower left screen, on the lower left side of the screen. And now all we have to do is say self.addChild player. Let's do some physical adjustments and say self.physicalWorld. We don't want that it has a gravity, so we have to use a vector. Let's say CG vector make. And this will actually give it a gravity of 0, 0, so no direction, which will cause our object to stand still. And let's also say physicsWorld.contactDelegate equals self. This is what we're going to use later for our collision testing, so that when a photon torpedo hits an alien ship, that we can detect whether they have collided or not. So this gives us an error because we haven't adopted the contact delegate yet, so we will just do that by writing a comma and say sk physics contact delegate right within the class definition. So our error is gone, and let's see whether we have our spaceship here. And there is our spaceship. Cool. We already have our player. Now it's time to add some aliens. Therefore, we are going to write our own function. So let's say function add alien, open curly braces. And the first thing again is we're going to create a node for our aliens. So let's call this node alien. And this is also, just like our player, a SK sprite node. We'll initialize it with, again, an image, which is in this case alien. All right. Now we will give this a physics body, which will enable us to detect collisions more easily, and which is also useful for simulating physical effects. We will just approximate this physical body because we do not really need all the details of the alien ship for a working physics here. So let's say alien dot physics body equals sk physics body, and we will then use the approximation of a rectangle. So rectangle of size, and we can just use the size of our alien for this approximation. So now we will set this the dynamic property, which says whether our object is moved by the physics of our scene. So let's set this to true. And we will now have to give our alien a category bitmask and a test bitmask, contact test bitmask, which are both responsible for the detection of a collision with the photon torpedo. So how do we do that? It is called a category bitmask. So we have to create two more properties here, which we can define as constants. So let's say let alien category, and this is of type uint32, and we will now give it a a bitmask using this strange looking code. It actually, what we are going to do here is a bitwise multiplication. So when we write this operator, we actually multiply this this expression by 1, and this is going to identify our alien when we are doing a collision with the photon torpedo. So let's also create a photon torpedo category u integer 32, and we will, to identify this and to give it a difference to this category, just multiply it with 0. So this is multiplied by 1 and this is multiplied by 0. And this is actually all you need to know to so that you can determine the difference between those two categories, and we're going to use them later. But for now, we're going to assign them to our alien. So let's say alien dot physics body dot category bitmask, and this is now the bitmask of our alien. So we'll use the alien category, and now again alien dot physics body, and now we use the contact test bitmask, which is going to identify the photon torpedo, our contact. And now we're going to define the collision bitmask, and this is set to 0. Now we will now we will have to give our alien a position on the x-axis. So we want this to be random, so that our aliens are coming from different positions to the bottom of the screen. So now let's position our aliens along the x-axis, and we're going to use a very easy approach to this. So we will use some constants, minimum x value, which will define the minimum x position on the left side. So this is actually the half of the alien ship size. And we will use another constant, which is max x value, and this is the frame. And we will subtract the hull size of the alien ship, and the range that we're going to use is the maximum value minus the minimum value, so that we have a nice range of possible positions where our alien ship can appear. And now we will have to do a random positioning, or get a random position for them. So let's create another constant, call it position. It's going to be a CG float because we're going to use it within a point later, and we will use arc for random to get a random number. Use the standard code for getting a random value, and we will then add the minimum x value to this, so that our alien ship is never off the screen. And now you will see that we have some errors here, because we have to cast all of our calculations here using the CG float cast operator. So let's do some parentheses here, say CG float, and we will cast this expression modulo CG float range x plus CG float min x. And now if we build, we still have an error. All right. 1 parenthesis too much. Still failed. Let's just call this range x. And now build succeeded. Cool. Now let's position our alien using the position property and using CG point make, and we will, for the x value we can now use our position, and for the y value let's say self.frame.size.height, which will be the upper side of the screen, and just add the height of our alien to move it slightly off screen. And now we'll just add our alien using add child, and that's it. Now we won't see anything of our alien yet because it's off screen. So it's time to bring a little movement into our game, and we will therefore use something called actions. But we will have to define the speed or the duration of such an animation, and we want all our alien ships to have a different speed, which will make the game a little more interesting. So we will use the same approach as we did with the random x position for the random speed of every alien ship. So again, we will have a minimum duration, which is, let's say, 2, and we'll have a max duration, which is 4, and we will have a range, which is the max value minus the min value, and we will then use again the arc for random expression to get a random number. This time we're going to cast it right away using an integer arc for random modulo integer range duration plus integer min duration. All right. Again, missing parenthesis. All right. And now we can start creating some actions. So we will create the action, an action array, and it's mutable array actually. And this array we're going to use to place some actions into it, and then use a sequence to run one action after another. So let's initialize the mutable array and add one action and then the next one. So add object to our mutable array, and we'll first want to move our spaceship. So let's call sk action dot move to, and we want to use the location and duration parameters. So the location actually is a CG point make, and we will use for the x value our position, because the x position of the alien ship shouldn't change. And for the y position, we will just use the negative height of an alien ship, so which will move it slightly beneath the bottom of the screen. So minus alien dot size dot height, and the duration is what we just calculated, and we have to cast this to an ns time interval. So let's just do it and say duration, and don't forget the closing parentheses, and then succeeded. Cool. Now let's the last thing we have to do with this animation is remove the alien ship as soon as it has left the screen. So let's also add to our action array this sk action, and this is actually just remove from parent. And now we will have to add this action array within a sequence to our alien. So let's just say alien.run action, and we'll now call skaction sequence, and we'll just pass in the action array, and this will sequence the first action we added to the array, and will then, after this is completed, run this action and remove the alien ship from our screen. So let's run this and see what's happening. I will just mute the audio for now. And of course, we can't see nothing yet because we haven't called the add alien method yet. Therefore, as I told you earlier, we have to use those two properties, which are going to help us decide when to create new aliens, because we do not want an indefinite number of aliens on screen. So we will write some new functions, and first of all, we start off with a function called update with time since last update. And it's going to have one parameter called time since last update. And this is a CF time interval. And what this method is going to do, it's first saying last yield time interval, and we will add the time since last update to this to this property, so that we know when the last yield of alien ships has been created, and we'll then check if this is more than a second last yield time interval. If this is greater than 1, we will set this back to 0 and call our add alien method. And now we won't see anything because this method won't be called either. So we have to call the update method, which has already been written for us by Xcode, because we have chosen this game template. We'll just remove that comment from here, and now we will say the time since last update equals the current time, which we get as a parameter here, minus the last update time interval. And now we'll set this, because we now have we have used this we've now used the last update time interval. We can now set it back to the current time. And say current time. And even here we will check if the time since last update is greater than 1. That would mean that we that more than a second has passed since the last update, and we'll then set it back to time since last update 1 divided by 60. And say last update time interval equals current time. And now, after this if statement, we will call our update with time since last update, and we'll pass the time since last update variable to our own function, which we'll then call the add alien function. So let's see what's happening. And there they are. Different speeds, different X positions. So far, so good. Now, in this tutorial, you have so far learned how to set up a SpriteKit game within Xcode. You have learned how to add your custom music as a background music. You've learned how to place your your players and your aliens on the screen, and how to make things move and how to position things. And let's break this up, and let's move on in a second tutorial when we will deal in which we are going to deal with firing and collision and so on.